Hello dear students, now let us see how to construct PDA for the language we were discussing in the previous video. So you recall the language was W raised to R or W reverse, given that W is 0, 1 closure. And we saw that in this language there are all even length palindromes, correct? And epsilon is also one of the members, empty string, which is indeed a palindrome of length 0. So what I thought before starting the video is, I will first show the solution. So this is the PDA, but just observe this is NPDA, non-deterministic pushdown automata. Can you find out why it is NPDA? Just pause the video and just ask yourselves, where do you see non-determinism over here? Okay, just observe that in the state Q0, in this state Q0, we have a configuration 0, 0. That means in state Q0, if the machine is reading 0 and top is 0, correct, is a configuration. But in the state Q0, same state, you watch, same state, we have got 0, 0 configuration again. So if you are describing delta, you will say Q0 when reads a 0 and top is 0, it can result in two possibilities, correct? One is where you will be seeing this particular result, and other is the pop result. And in the second result, you will be entering Q1 state. Similarly, you can see 1, 1. Just check this, Q0, 1, 1. And you can see this for the same state Q0 with 1, 1 configuration. There are two results. So clearly this is NPDA. Now what is the idea? Just observe that in this slide I will just tell you the general idea, and then very quickly we will run through this PDA. But just first of all take an idea. The idea will be as usual, that for every 0 we will push X. For each 0 push X, and for each 1 push Y, so that you can remember whether you encountered 0 in the input or 1 in the input by loading them on the stack in the form of X and Y. But this is only till we reach center, because once we reach the center, you can see that this is one part of the string here, just observe, and this is reverse. So as soon as you enter the second part of the string, you should start pop operation. But the big question is, how will our PDA come to know that it has reached center? And the answer is, it won't know. It won't know whether it has reached the center. The only thing that PDA will do is that whenever a symbol like 1 is immediately followed by same symbol 1, just observe, if 1 is followed by 1, then PDA will assume that it has reached center, and PDA will also assume that it has not reached the center. Oh my god. Let's just check it. Whenever there is 0 followed by 0, just check, symbol followed by same symbol, then PDA will assume two things, that it has reached the center, and second thing it will assume is it has not reached the center. So you will see typically for 1, 1 and 0, 0, you will have two results, as I was saying. Let's elaborate on this point, okay? So I am taking this string which I have drawn over here. This is 0, 1, 0, 1. I'll read right. The string is 0, 1, 0, 1, and its reverse will be 1, 0, 1, 0. Okay, let's start working on this. And what I am going to show here is the stack. On this line I will show the stack, and initially the top is Z0. Now the idea is, when we read the first 0, the top is Z0, so we'll push X. Now look, from here you see the top of the stack. So top of the stack now is X. Now watch, we are reading a 1. But when we are reading a 1, top is X. Then we will push Y. For every 1 we will push Y. We are reading a 0. Then we will push X. We are reading a 1. We will push Y. We are reading a 1. Here comes the interesting point. Just check, we are reading a 1. But symbol before this, just before this, was 1. How does PDA come to know that the symbol before this was 1? Come on, it will contact the stack. And the stack is having topmost symbol as Y, and you are reading 1. That means 1 is followed by 1. Then it will start assuming two things. First thing is, center is not reached. If center is not reached, if it is assuming that, then what it would do is, it will take two possibilities. Just check, here starts the interesting thing. The two possibilities is 0, 1, 0, 1, 1, 0, 1, 0, and right now we have Z0, X, Y, and we are reading this one. What if PDA assumes center is not reached? Then it will push, because center is not reached, so it doesn't have to start the pop operation. The second assumption it will do is that when we are reading that 1, let me draw the string again. When we are reading this 1, just before that 1 was there, then the stack, as you see, is Z0, X, Y, X, Y. Now, it is reading a 1 just before that 1 was encountered. So it will assume that center is reached. This portion here is, it is assuming center is not reached. So it will keep pushing. This portion is center is reached, or center has been already surpassed. So what it will do for this one? For this one, it will pop Y. What it will do for this 0? For this 0, it will pop X. For this one, which I am right now marking, it will pop Y, because 1 matches with 1. And for the last 0, it will pop X. And when epsilon is reached, Z0 is encountered, where Z0 says that whatever you had pushed has been popped. So that's the PDA that you are going to get. Now, to better understand it, we will take a very small string. We will not take such a large string, and we will not run the PDA on very large string. Okay, but let's take a string like this. I'm taking a string 0, 0. Oh, this is a palindrome. We start in Q0 state, and currently the top is Z0 initially. What are we going to do when Q0 reads a 0, first 0, top is Z0? We will be pushing X, because 0 is remembered as X, and now this 0 remains, the second 0. Now the fun part starts. Q0 is reading a 0 and top is X. Now you tell me, if top is X, that means just before this 0, 0 was present. That means 0 is followed by 0. We are at this second 0 and top is X. So now PDA will assume two things, that center is reached or center is not reached. So first action it will take is, it will say, let me think that center is not reached. So for this 0, it will push one more X. You can see this X and Z0 remain, and one more extra X has been pushed, and epsilon remains on the input, because even the 0 is consumed, so epsilon remains. Now you can see that this is a dirty configuration. You can stop here. This is dirty, because what should Q0 state do when input is epsilon and top is X? Such a configuration is not defined anywhere. You can see Q0 epsilon Z0 is defined, this one, but such a configuration is not defined. Okay, what is the other action that PDA can take? Is it can say that center is reached. So if the center is reached, then for this 0, it will say, okay, top is X, so I'll pop the X. So in that case, what we will get is Q0 epsilon Z0. You can see that on the stack X was present, this X, but it has been now popped. And now we are perfectly having that. Oh yeah, one more thing, it will enter Q1 state. I'm so sorry. It will enter this Q1 state for this 0, 0 epsilon. And now in Q1 state, when machine is reading nothing and top is Z0, it will enter Q2 state, keeping Z0 as Z0. The most important thing in this problem, was where do you explain non-determinism? Where do you explain non-determinism of this PDA? If the string is 1 0 1 1, let's say 0 1 1 0 1 1 0 1, this is a palindrome. Whenever there is a input repeating itself, PDA assumes two things: that center is not reached or center is reached. Just check here. For this one followed by this one, it will assume that center is reached or center is not reached. Both the things will be assumed, even for this. So two actions will be taken by PDA, and one of the actions will take us to the final result. I would suggest all of you to draw this PDA on paper and take some string on your own and just follow the transitions and just check how non-determinism is carried out over here and how palindromes will be accepted. It will be great if you also check how epsilon is accepted, because epsilon is the part of our language. So even if we feed empty string over here to this PDA, it should reach the final state. It should reach the final state because epsilon should be accepted. It is a even length palindrome. So that's it. This is how the NPDA is developed. Thank you very much.